Hello, good evening, everyone. I hope you all are fine. In the last class, we have seen with respect to capillarity and numerical problems on that, and all, that also concludes our first module. Now, what we will do is we will solve some additional problems on the topics which we have covered. So, I am sharing the screen. I hope it is visible to you. So, the first problem is on Newton's law of viscosity. So if the velocity distribution over a plate is given by u is equal to 2 by 3 y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate. Determine the shear stress at y equal to 0 and y equal to 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. So what we are assuming, the velocity distribution over a plate is given by the equation, that is u is equal to 2 by 3y minus y square, in which u is the velocity in meter per second and at a distance y above the plate. So what you need to calculate? You need to calculate the shear stress at y equal to 0 and y equal to 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. So this is first u is equal to 2 by 3 y minus y square. So we need to differentiate this with respect to y. So du by dy is equal to 2 by 3, differentiation of y is 1, minus differentiation of y square is 2y. That is du by dy at y equal to 0. 2 by 3 minus 2 y we are substituting as 0. So it comes out to be 2 by 3 or 0.667. In the second case, we need to calculate du by dy at y equal to 0.15 meter. 2 by 3 minus 2 into y is nothing but 0.15. So it comes out to be 0.367. Now, value of mu is given as 8.63 poise. So how you will convert this to Newton second per meter square? Multiply by 0.1 or divide by 10. So it comes out to be 0.863 Newton second per meter square. Now the shear stress equation as per Newton's law of viscosity, that is shear stress acting on the fluid element is directly proportional to rate of change of shear strain. So your tau is equal to mu into du by dy. So in the first case, shear stress at y equal to 0 is given by tau 0 is equal to mu du by dy at y equal to 0. Mu is how much? 0.863. So du by dy at y equal to 0, just now you have calculated, that is 0.667. So the answer comes out to be 0.5756 Newton per meter square. In the second case, shear stress at y equal to 0.15 meter is given by 2 y 0.15 mu into du by dy at y equal to 0.15. 0.863. This you have calculated u by dy at y equal to 0.5, 0.367. So it comes out to be 0.3167 Newton per meter square. So one more problem is there. A plate 0.025 mm distant from a fixed plate moves at 60 centimeter per second and requires a force of 2 Newton per unit area, that is 2 Newton per meter square, to maintain this speed. Determine the fluid viscosity between the plates. So what is given to you? Distance between the plates. dy is given to us 0.025 mm. Velocity of upper plate. U is equal to velocity required to move the plate 60 centimeter per second. So you convert this into meter per second, it comes out to 0.6 meter per second. Now force on the upper plate. So how much is the force on the upper plate? 2 Newton per meter square. This is the value of shear stress 2. Now what you need to calculate? Viscosity. So what we are assuming, let the fluid viscosity between the plates is mu. Now, using the equation of Newton's law of viscosity, 2 is equal to mu into du by dy, where du is equal to change in velocity, u minus 0. Here the velocity is not changing, so u comes out to be 0.6 meter per second only. Similarly, dy is equal to change in distance. It is given to you 0.025 into 10 raised to minus 3 meter. 2 is also given to you force per unit area 20 Newton per meter square. Sorry, 2 Newton per meter square. So 2 is given to us 2. Mu into du is 0.6. dy is 0.025 into 10 to minus 3. So if you do the calculation, it comes out to be 8.33 into 10 raised to 5 Newton second per meter square. So if you want to convert this into poise, it will be 8.633 into 10 raised to minus 4 poise. So one more problem. Determine the specific gravity. Determine the specific gravity of a fluid having viscosity 0.05 poise and kinematic viscosity 0.035 Stokes. So this is a somewhat new type of problem in which two types of viscosity is given. That is dynamic viscosity is also given to you and kinematic viscosity is also given to you. So what you need to calculate? You need to calculate specific gravity. So viscosity mu is equal to 0.05 poise. So it comes out to be 0.05 divided by 10 Newton second per meter square. Kinematic viscosity V is given to as 0.035 Stokes. So it is in order to convert this into meter square per second, multiply by 10 raised to minus 4. So kinematic viscosity comes out to be 0.035 into 10 raised to minus 4 meter square per second. Now we have the relation V is equal to mu by rho. So V is, that is kinematic viscosity is 0.035 into 10 raised to minus 4 equal to mu is also given to you 0.015 divided by 2 into 1 by rho. So your rho comes out to be 1428.5 kg per meter cube. So this is a very interesting type of problem in which both the type of viscosity is given to you, with the help of which you are calculating the density and finally the specific gravity of liquid. So the density of the liquid comes out to be 1428.5 kg per meter cube. Now we know the definition of specific gravity of liquid, that is specific gravity of liquid is nothing but density of liquid to density of water. Your standard density of water is 1000. So 1428.5 divided by 1000 comes out to be 1.4285. If you just round it out, it will be 1.43. No unit because it is specific gravity. Now we will solve one more problem in which we need to calculate the viscosity of liquid having kinematic viscosity 6 Stoke and specific gravity 1.9. So it is similar to the above problem, only the thing is there. In the first case, both type of viscosity was given to you and you need to calculate the specific gravity. Here, one type of viscosity and specific gravity is given. You need to find out the another type of viscosity. First, viscosity. Kinematic viscosity is given to us 6 Stokes. So this you will convert to meter square per second by multiplying by 10 raised to minus 4. Specific gravity is how much? 1.9. So you need to calculate the viscosity. That is dynamic viscosity we need to calculate. That is assumed to be the now specific gravity of liquid is density of liquid to density of water. Specific gravity is 1.9. Density of liquid you need to calculate divided by 1000. That is density of water. So density of liquid is nothing but 1000 into 1000 into 1.9. So it almost equal to 1900 kg per meter cube. Now we have the relation V is equal to mu by rho, where V is the kinematic viscosity, 6 into 10 raised to minus 4, equal to mu divided by rho is nothing but density. It, it comes out to be 1900. So your mu is equal to how much? It comes out to be 1.14 Newton second per meter square, or your mu is equal to 11.40 poise. So your mu comes out to be 11.40 poise or 1.14 Newton second per meter square. Now we will solve one more problem in which the velocity distribution for a flow over a flat plate is given by u is equal to 3 by 4 y minus y square, in which u is the velocity in meter per second at a distance y apart. You need to calculate the shear stress as y equal to 0.15 meter, taking dynamic viscosity of fluid as 8.6 poise. So your u comes out to be, first, you need to differentiate this equation. Du by dy is equal to 3 by 4. Y is nothing. Differentiation of y is 1 minus 2. Differentiation of y square is 2y. At y equal to 0.15. Du by dy equal to 3 by 4 minus 2 into 0.15. It comes out to be 0.45. Mu is equal to 8.5 poise or 8.5 Newton second per meter square divided by 10. So your 2 is equal to mu into du by dy. So 2 is nothing but 8.5 by 10 into mu is 0.45 Newton second per meter square. So finally it comes out to be 0.385 Newton meter square. Now we will solve some problems on what you can say. Uh, it is also a problem on viscosity of water only. We will just roll what are the problems available. It's almost over. So we will solve that only. The space between two square flat parallel plates is filled with oil. Each side of the plate is 60 centimeter. The thickness of the oil film is 12.5 mm. The upper plate which moves at 2.5 meter per second requires a force of 98.1 to maintain the speed. Determine the dynamic viscosity of the soil in poise and kinematic viscosity of the oil in Stokes if the specific gravity of the oil is 0.95. So it is also a very interesting problem. So you just read it once again. What is happening? The space between two flat parallel plates is filled with oil. दो स्क्वायर प्लेट हैं जिसके बीच की जगह किससे भरी हुई है? ऑयल से. द स्पेस बिटवीन टू स्क्वायर प्लेट्स पैरेलल प्लेट्स इज फिल्ड विथ ऑयल. Each side of the plate is 60 centimeter. Each side of the plate is given to us 60 centimeter. The thickness of the oil film is 12.5 mm. Thickness of the oil film is given to us 12.5 mm. dy is given to you. And area side is given to you 0.60 centimeter. The upper plate which moves at 2.5 meter per second. So what is the velocity required to move the plate? 2.5 meter per second. And it requires a force of 98.1 Newton. So how much is the force required to move the plate? 98.1 Newton to maintain the speed. So these are the things given to you. So what you need to calculate? Determine dynamic viscosity of the soil in poise. You need to determine dynamic viscosity of the soil in poise and also kinematic viscosity of the soil in Stokes. Kinematic viscosity of the oil you need to calculate in Stokes. If the specific gravity of the oil is 0.85. So first we will write down the things which are given to you. Each side of the plate is 60 centimeter. So it comes out to be 0.6 meter. Because it is a square plate, the area will be a square. 0.6 into 0.6. So it comes out to be 0.36 meter square. Now the thickness of the oil film dy is equal to 12.5 mm. So if you convert this, it will be 12.5 10 raised to minus 3 meter. And the velocity of the upper plate u is equal to 2.5 meter per second. That is change of velocity between the plates du is equal to 2.5 meter per second. And the force required on the upper plate is given to us 98.1 Newton. So using this, you can calculate shear stress. So what is shear stress? Force by area. Force is 98.1, area is 0.36. Now let mu is equal to dynamic viscosity of oil. So your 2 is equal to mu into du by dy. So mu into what you can say 98.5 is the force, 0.36 is the area. So using this du and dy is also given to you. Du is 2.5, dy is 12.5. So if you do the calculation, it comes out to be 13.635 poise, because 1 Newton second per meter square is equal to 10 poise. So it comes out to be 13.635 poise. In the second bit, you need to calculate the specific gravity of oil is given to us 0.95. Let V equal to kinematic viscosity of oil. So using equation 1.1a, mass density of oil is sigma equal to S into 1000. That is, S is nothing but space gravity. Into 1000, if you do, you will get the density of oil. It comes out to be 950 kg per meter cube. Now again, using the relation V is equal to mu by pi, we get V equal to mu is 13.635 newtons second per meter square divided by rho is how much? 950. So if you do the calculation, it comes out to be 14.35 Stokes, because centimeter square per second is equal to Stokes. And in order to convert this into what you can say Stokes, you need to multiply by 10 raised to minus 4. This problem already we did. This also we did. This also we did. No, this we need to calculate. Find the kinematic viscosity of an oil having 981 kg per meter cube as the kinematic viscosity. Sorry, density is how much? 981 kg per meter cube. You need to calculate kinematic viscosity. The shear stress at a point is given to us 0.2452 Newton per square, and velocity gradient at that point is 0.2 per second. Velocity gradient is given to you. That is 0 du by dy is given to us 0.2 second. Mass density rho is nothing but 981 kg per meter cube. Shear stress tau is equal to 0.2452. So using the equation, tau is equal to mu into du by dy, or tau is nothing but 0.2452 equal to mu into du by y is 0.2. So your mu comes out to be what you can say 1.226 Newton second per meter square. Now kinematic viscosity V is given by V equal to mu by rho. So mu is nothing but 1.226 divided by rho is 981. So it comes out to be 0.125 into 10 raised to minus 2 meters square per second. So it comes out to be 12.5 centimeter square per second, or Stokes, because centimeter square per second is equal to Stokes. So this almost completes our first module. If you have any doubt, you can just comment on the videos. If not, we will go to the next module. I will just recall the things from the starting. So our module 1 started with definition of fluid, properties of fluid, mass density, specific weight, specific gravity, specific volume. Later on, we calculated what do you mean by cohesion, adhesion. Next, we calculated viscosity and its types, Newton's law of viscosity. Next, capillarity, capillary rise and fall in the vertical tube. Finally, we studied about surface tension, what is the surface tension in case of water droplets, soap bubble, and liquid jet. Also, we solve numerical problems. So, what exactly is a fluid? A fluid is substance which undergo continuous deformation under the application of loads. Next, properties of fluid density, nothing but mass by volume. SI unit is kg per meter cube. Weight density is weight by volume. SI unit is Newton per meter cube. W is equal to mg, that is weight is equal to mass into acceleration due to gravity. Specific gravity or relative density is nothing but density of fluid divided by density of standard fluid. This was very important definition, as it was helpful in while calculating the while solving the problems. We will stop for 2 minutes because Aza is going on. Okay, we will continue now. I'm sharing the screen. I hope it is visible to you. So next we studied about specific gravity. So what was specific gravity? It is nothing but ratio of density of fluid to density of standard fluid. Standard fluid, we assume water to be standard fluid, whose density was 1000 kg per meter cube. Next, it is a dimensionless quantity. Specific volume is nothing but ratio of volume of mass. I say it is meter cube per kg. After that, we solved some problems on this. Next, cohesion and adhesion we studied. Cohesion is nothing but force acting between molecules of same kind, whereas adhesion is nothing but force acting between molecules of different kind. Then we studied the examples for surface tension. Cohesive force. For instance, rain falls in droplets rather than a fine mist because water has strong cohesion which pulls its molecules tightly together, forming droplet. So during rainy season, if you have observed, when the water droplets fall on a leaf, it will stuck to it due to the cohesive force between the molecules. Similarly, example for adhesive forces, that is force acting between molecules of unlike kinds. When water is poured on a clean glass, it tends to spread, forming a thin uniform film over the glass surface. This is due to the unlike force acting between it. Then we studied about viscosity. Viscosity is nothing but property of a fluid by virtue of which one layer of the fluid opposes the flow of another layer. Then we studied Newton's law of viscosity, which said that shear stress acting on the fluid element is directly proportional to shear strain. Rho is equal to mu into du by dy, where mu is the known as dynamic viscosity or coefficient of viscosity. Its unit is Poise and Newton second per meter square. Next is kinematic viscosity. It is the ratio of dynamic viscosity of the fluid to the density of the fluid. So it is unit is meter square per second. Then we solve some numericals on viscosity. And then we studied about different types of fluid, ideal fluid, a real fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. So ideal fluid is nothing but a fluid which has no viscosity and it is incompressible. Although such type of fluid does not exist, we assume for our study or research purpose. Next comes new real fluid. Almost all the fluids which are available are nothing but real fluids only. Whereas next Newtonian fluid, nothing but a fluid which obeys Newton's law of viscosity, that is shear stress is directly proportional to shear strain. Next type of fluid is non-Newtonian fluid, which does not obey Newton's law of viscosity. Last but not the least, it is ideal plastic fluid. It is nothing but a real fluid in which the shear stress is more than the output or yield, and the shear stress is proportional to rate of change of shear strain or velocity gradient. Next, we studied about surface tension. So, what is surface tension? It is nothing but tensile force acting on the surface of a liquid in contact with the gas or in between two immiscible liquids. Liquids which cannot be mixed. For example, water and petrol. If you mix, then in between them there will be thin film bond between them. So, these type of fluids are termed as immiscible liquids. So what is the SI unit of surface tension? Newton per meter. So how we are explaining surface tension to the student? We are assuming that three bubbles are inserted in water. The bubble A is completely inserted in water, as a result of which all the forces are acting on it, and the resultant force acting on it will be zero. Similarly, bubble B is 80% inside water and 20% above the water, as a result of which the forces acting on it are unbalanced. In the last case, the liquid droplet is cut is is cut into is cut into two halves, and the molecule C, it is 50% inside water and 50% at the top, as a result of which the surface or the center point behave as a thin film and surface tension act on it. The same unit for surface tension is Newton per meter. After that, we calculated surface tension of liquid droplet, assuming the forces to be in equilibrium. So it comes out to be sigma equal to PD by 4. Similarly, we calculated surface tension of hollow bubble, as both the surfaces are in contact with air. it comes out to be P equal to 8 sigma by D, or your sigma surface tension equal to PD by 8. Finally, we calculated surface tension of liquid jet. It comes out to be sigma equal to PD by 2. So PD by 4, PD by 8, and PD by 2 is the surface tension for different cases. So bubble, hollow bubble, or liquid droplet, or in liquid jet. Finally, we come to the last part of the module 1, that is capillarity. So what was capillarity? Capillarity is nothing but the sudden rise or fall in the level of liquid when a glass tube is inserted in beaker. What will happen? There will be a rise in the level of liquid adjacent to the layer, or there will be decrease in the level. If suppose there is increase, then it is termed as capillary rise. And the formula to calculate capillary rise is H equal to 4 sigma cos theta divided by rho GD, where what you can say, theta is equal to 0 degree in case of water, whereas theta is equal to 120 degree in case of mercury. So how you will define capillary fall? Capillary fall is nothing but the reduction in the level and the fall in the level of water in the glass tube when it is inserted in it. Normally, capillary fall is observed in case of mercury whose density is more, that is 13.6 into 1000. It comes out to be almost 1360 kg per meter cube. Capillary fall is identified by the negative sign. So after that, we calculated some problems for capillary rise and capillary fall, assuming that diameter is given by d and h is equal to 4 sigma cos theta divided by rho d. So using both the formulas, we calculated the problems or we solve the problems. It is very simple and easy problem, but don't get confused or else you will lose marks. So h is equal to 4 sigma cos theta divided by rho GD. For capillary rise, theta is equal to 0. So cos 0 is almost equal to 1. So your h equal to, so it become 4 sigma cos theta by rho GD. In case of mercury, theta is equal to 128 or 130 degree. So cos h equal to 4 sigma cos 128 or 130 divided by rho GD. So you will get the desired value. So the negative sign indicate there is a capillary fall in the tube. So carefully you take the instruments, carefully handle it, don't get confused. It is a very important module 1 because the entire physics is dependent on this topic. If you are unable to understand this topic, then you cannot understand anything. So just try to remember the definition of fluid, the properties of fluid, light density of fluid, specific weight, weight density, specific gravity. All these things, if you remember, then easily you can solve the problems and also appear in the exam. Density, mass by volume, specific weight by volume, specific volume, what you can say, volume, density, mass by volume, specific weight by volume, so volume by mass. So this type of things you can easily calculate. Next, surface tension unit is Newton per meter. Capillarity unit is meter or centimeter. H is equal to 4 sigma cos theta by rho GD. Next, other than this, what you can say, viscosity is there, kinematic viscosity is there, dynamic viscosity is there, shear stress is directly proportional to shear strain is also there. So all these things will be helpful. Still, if you have any doubt, you can just comment in me or you can directly contact to me. You can just put a mail at the Also, you can call me at any time at 8553 171859. So thank you, friends. In the next class, we will start with another module. I hope you are having a good time. Thank you, one and all.